In the boardrooms of Nagoya, Toyota operated for decades under one unshakable principle: build everything yourselves. Yet today, on the streets of Beijing, a Toyota sedan carries a battery stamped with the logo of its fiercest rival, BYD. To outside observers, this looks like a surrender, proof that Chinese engineering has overtaken the world's most self-reliant automaker. But the reality is a calculated survival strategy, one that reveals how Toyota is borrowing its rival's technology while quietly building something bigger behind the scenes. This arrangement raises three questions worth examining in detail. Why did the world's most self-reliant automaker abandon its own supply chain for a competitor's technology? Is BYD's Blade battery genuinely as safe and cost-effective as its test results suggest? And what does Toyota intend to do once this arrangement has served its purpose? Answering these requires looking closely at the market pressure that forced Toyota's hand, the engineering behind BYD's battery, and the long-term plan Toyota is funding in the background. For decades, Toyota built its empire on total control. The Toyota production system turned supply chains into a science, and the Prius made Toyota synonymous with hybrid dominance. Full electric vehicles were treated with skepticism, and Toyota bet on hybrids and hydrogen instead, convinced the world was not ready to go all in on batteries. That bet paid off for years, since hybrid technology allowed Toyota to reduce emissions without requiring the charging infrastructure or battery supply chains that full electric vehicles demanded. Then, China stopped waiting. New energy vehicles, the official term covering EVs and plug-in hybrids, officially crossed 50% of total new car sales in China. Combustion engines and traditional hybrids started losing ground fast. Toyota and Volkswagen watched their gas and hybrid sales drop 15 to 20% in just 12 to 18 months. That is not a slow decline. That is a market shifting within a single product cycle. For Toyota, the message was direct: adapt immediately or lose the world's most important car market entirely. This detail makes the situation notable. Toyota is not a struggling latecomer scrambling to catch up. This is the company that wrote the modern manual on manufacturing discipline, the company other automakers studied and copied for decades. Every major manufacturer, from Detroit to Stuttgart, has spent years attempting to replicate the efficiency Toyota built into its factory floors. Even Toyota's playbook had no answer for how fast China's EV market was moving. That signals a broader shift. The entire industry's rules changed, and Toyota was not exempt. Manufacturing discipline, the very foundation of Toyota's global reputation, proved insufficient against the speed of a market transformation measured in months rather than years. In an electric vehicle, the battery is the single most expensive part of the car, often 30 to 40% of total production cost. Miscalculating that number erodes margins before a single unit sells. Toyota faced a direct choice: build its own battery supply chain from the ground up or buy in. Building meant billions in capital, years spent securing lithium, nickel, and cobalt supply, and a manufacturing learning curve measured in years, not months. Toyota did not have years. Every quarter spent building a battery ecosystem from scratch was another quarter losing ground in China, watching local competitors ship new EVs while Toyota was still securing raw materials. During that same period, Chinese manufacturers including BYD continued releasing new EV models at a pace that established international automakers had not previously needed to match. Time, not money, was the real constraint, and time was the one resource Toyota could not manufacture on demand. A company can direct unlimited capital toward a gigafactory, but it cannot compress the years required to stabilize production quality, negotiate raw material contracts, and train a workforce to build battery cells at scale. Raw material sourcing alone involves securing long-term contracts across multiple continents, since lithium, nickel, and cobalt supply chains are concentrated in a small number of countries and controlled by a limited number of suppliers. The market Toyota needed to serve was moving in months, not years, and that mismatch is what pushed Toyota toward a partner that had already solved the problem. Rather than compete against an accelerating timeline with an unfinished supply chain, Toyota chose to acquire proven technology and redirect its internal resources elsewhere. To understand why Toyota turned to BYD specifically, its origin matters. BYD began in 1995 making batteries for mobile phones and only later expanded into automobiles. That history means BYD controls its battery production in-house, from raw cell to finished pack, giving it tight cost control and the ability to iterate quickly without relying on outside suppliers. Few automakers can claim that level of vertical integration, since most rely on third-party cell manufacturers and negotiate pricing and supply terms externally. BYD's structure removes that dependency entirely, which allows the company to adjust its chemistry, cell design, and production process without waiting on an outside partner's timeline. Most premium EVs use NMC batteries, nickel, manganese, cobalt, which offer higher energy density, but come at a cost. They are expensive and carry a real risk of thermal runaway. BYD took a different approach with LFP, lithium iron phosphate, cheaper raw materials, a more stable chemistry, a longer usable lifespan measured in thousands of charge cycles, and no dependence on scarce, expensive metals. The battery's design is what gives it its name. Instead of stacking bulky modules with wasted space between them, BYD uses cell-to-pack technology, arranging long, thin cells like blades directly inside the pack and skipping the intermediate module stage entirely. That structural approach increases volumetric energy density by roughly 50% compared to traditional LFP packs while reducing bulk and improving overall efficiency. Combined, the cheaper chemistry and smarter structural layout produce measurable results. The Blade battery holds up for more than 3,000 charge cycles, equivalent to over 1.2 million kilometers of driving before meaningful degradation. And because it skips nickel and cobalt entirely, it costs roughly 20 to 30% less to produce than an NMC pack of the same capacity. For a company built on cost discipline and safety, that combination is difficult to match. The nail penetration test demonstrates why this battery earned Toyota's trust. It is the industry's most demanding stress test, a nail driven directly through a charged battery cell. A standard NMC battery punctured this way spikes past 500 degrees Celsius almost instantly and erupts into flame. BYD's Blade battery, under the identical test, holds a stable surface temperature between just 30 and 60 degrees Celsius. No smoke, no explosion. For Toyota, that single result carries more weight than any performance specification. Toyota's brand identity centers on one concept: reliability. A battery that survives physical puncture without becoming a fire hazard allows Toyota to apply its badge without hesitation. This matters because battery fires remain one of the most publicized safety concerns surrounding electric vehicles, and a single high-profile incident can damage consumer confidence across an entire product line. Because LFP is inherently inexpensive to produce, it also allows Toyota to compete on price in a market currently defined by aggressive price competition, where Chinese manufacturers routinely undercut established international brands on cost. This alliance did not emerge overnight. In 2019, Toyota and BYD formed BYD Toyota EV Technology Company Limited, a 50-50 joint venture built for shared research and development. The division of labor is clear. BYD supplies the EV platform, the Blade battery, the electric motors, and the software integration. Toyota contributes vehicle engineering, suspension tuning, its own quality control standards, and decades of brand trust. The clearest proof of this arrangement is the Toyota BZ3 sedan, built specifically for the Chinese market. Underneath Toyota's body styling and safety engineering sits BYD's battery and motor system. The pricing illustrates the strategy directly. It starts at roughly 169,800 yuan, around $24,000, an aggressive figure for a Toyota-badged EV. Buyers can choose between a 49.9 or 65.3 kilowatt-hours Blade pack, delivering between 517 and 616 kilometers of range on China's key LTC test cycle, with fast charging from 30 to 80% in just 27 minutes. The significance of the BZ3 extends beyond its existence. Toyota avoided spending years reinventing an EV platform from scratch. It took a battery and motor system already validated on Chinese roads, wrapped it in Toyota's engineering standards and quality control, and shipped a competitive product in a fraction of the usual development timeline. Development cycles for a new EV platform built entirely in-house typically extend well beyond 4 years when accounting for battery validation, crash testing, and regulatory certification. By adopting a proven platform, Toyota compressed that timeline substantially while still applying its own suspension tuning, safety engineering, and quality control processes on top of BYD's underlying hardware. This arrangement challenges a long-standing assumption in the auto industry. Toyota and BYD compete directly for the same customers, yet they are co-developing technology together. Industry observers describe this dynamic as co-opetition, rivals cooperating because pure competition alone is no longer sustainable. Remaining strictly separate, refusing to work with a competitor on principle has become a luxury few automakers can afford. This deal is not one-sided. Partnering with Toyota validates BYD as a genuine Tier 1 global technology supplier, rather than solely a domestic Chinese automaker. That validation strengthens BYD's global ambitions more than most marketing campaigns could achieve. It also allows BYD to monetize spare battery production capacity by selling to outside manufacturers, converting unused capacity into an additional revenue stream. Viewed without the surface-level framing, this is not a story of one company rescuing another. It reflects two companies with different core strengths, one dominant in battery technology, the other in brand trust and engineering discipline, recognizing that combining those strengths advances both faster than continued isolated competition. This pattern is not isolated to Toyota and BYD. Across the global auto industry, competing manufacturers have increasingly formed joint ventures and technology-sharing agreements specifically for battery development, since the capital and time required to build independent battery ecosystems has become a barrier even for companies with substantial resources. This raises a direct question. Has Toyota abandoned its position as an engineering leader? The more accurate interpretation is pragmatism rather than surrender. Sacrificing a portion of self-sufficiency in the short term is a measured trade-off for remaining competitive in the world's largest car market. While the BZ3 continues production, Toyota is investing in next-generation solid-state battery technology, targeting a commercial launch between 2027 and 2028. The target specifications are substantial: a driving range beyond 1,000 kilometers, with fast charging that restores most of that range in just 10 minutes. Solid-state batteries are expected to deliver faster charging, longer range, and greater safety margins than current lithium chemistries, and Toyota has spent years positioning itself among the leaders in that development race. Toyota's approach to this transition differs from competitors that have attempted to build solid-state and next-generation battery capacity entirely from internal funding, often at the expense of near-term product competitiveness. The strategy operates on three layers. First, use BYD's proven technology to remain competitive in China's current EV market, without spending years building a battery supply chain from zero. Second, sustain the business through Toyota's global hybrid operations, which BYD and most Chinese competitors do not have at comparable scale. Toyota sells more than 3.4 million hybrid vehicles worldwide every year, generating substantial net cash flow that funds this research without exposing the company to financial risk. Third, direct that funding toward the technological transition that could position Toyota ahead of the industry once solid-state batteries reach mass production. This is not Toyota conceding the competition. It reflects a decision to secure the time needed to compete on its own terms later, rather than being forced to compete today with unfinished technology. Solid-state batteries eliminate the liquid electrolyte used in conventional lithium-ion cells, replacing it with a solid material that reduces fire risk further while enabling higher energy density within the same physical volume. If Toyota reaches commercial production within its stated 2027 to 2028 window, the resulting range and charging figures would exceed what BYD's current Blade battery, or any LFP-based pack on the market, is capable of delivering. Viewed in full, Toyota's partnership with BYD was not a moment of weakness. It was a pragmatic adjustment by a company positioning itself to remain competitive in a rapidly shifting market. It also demonstrates how far BYD has evolved, from a phone battery manufacturer into a recognized global player in energy technology, while revealing a side of Toyota rarely visible to the public: operational flexibility when commercial survival requires it. The broader implication extends past these two companies. Supply chain flexibility has increasingly replaced absolute self-sufficiency as a determining competitive factor. Automakers that maintain the position that every component must be built in-house face increased risk of falling behind, while those willing to collaborate and adapt remain positioned to compete as the market continues to shift. This shift is already visible beyond Toyota, as multiple legacy automakers in Europe and North America have entered similar battery sourcing or technology licensing agreements with Chinese suppliers over the past several years, driven by the same cost and timeline pressures that shaped Toyota's decision. The transition to electric mobility has made one distinction clear: market position is not determined by a company's insistence on independent production. It is determined by the willingness to use every available resource, including technology sourced from a direct competitor, to remain viable in a market that no longer waits for any single manufacturer to catch up.